So what we're going to do now is we're going to place component again, and we're going to look for our pump front cover stock.ipt. That's the stock that we created and exported on its own. And we're just going to place this out in space. The reason why is because we're going to want to constrain this using mates to be able to put these two together. Within the relationships panel up at the top of the assembly tab is where you're going to use your joints and constraints. The difference between joints and constraints is joints are a little more fluid tools that allow for motion and movement, and they're a little more advanced than typical constraints. Constraints are two faces put together in a specific form and fashion. We're going to use constraints to assemble these two components together, and we're going to use the simple mate constraint. So what mate means is if you were to put your hands out in front of you and place them together as if you were clapping, that's two faces mating together. Now your other option here to the right is a mate flush. If you were to put your hands out in front of you again and just bump your hands finger to finger together, not putting them into a clapping motion, that's putting those two surfaces flush together. Now I explain it like that because it can be very confusing sometimes which mate you're wanting to select. So let's go ahead and do our first mate. Now with this component we have a datum that actually mates together quite well, and that's a cylindrical mate. Now you'll see here if I hover over this cylindrical surface I actually get the center line. That means that it's going to be using that center line to mate itself together. So I'm going to click on that cylinder. I'm going to click on the cylinder on the part itself. Now you'll see since the part is the grounded component and we selected the component to move, then we select the component to ground to, that the stock component moved itself to our grounded part component. So I can either hit apply here up in the dialog box, or I can right click and I can hit apply up in the right click menu. Now that I've hit apply, I'm ready to mate my next mate. We do have some added stock on this part where we're going to be machining it, so I want to actually mate, and I want to mate flush a couple of components, but I'm going to need to move them around. Now you'll see that I have a mate selected, so those two faces mated together. What I'm actually going to want to do is a mate flush, and just by clicking it over, it updated itself. Well, I need to have some material removal at the top there. So what I really need to do is I need to actually give myself what I need to machine off. Now it being a casting, it's going to be actually quite a bit, so I might actually do 50 thousandths, and you'll see that because the mates were selected in the opposite fashion, I may actually have to turn this into a minus. And you'll see that that actually pushed itself up the 50 thousandths that I need above the part. Now you can go ahead and take and turn this to wireframe over here on the side to take a look at that and see where those two are. So make sure that you have that 50 thousandths for the casting clearance. You can also take and split this number, do the math if you want to. This actually may be more like a 16th. Now I hit enter. Now that's okay. I actually hit enter and I did it in a positive direction, which was incorrect. So I can always close this out, come over to my model browser, click on the components, dropping the plus sign down so I can drill into the component itself, and you'll see that the mates show up right here. I can also come up into the relationship folder at the top to see all of the mates in a listing in the order that I created them. And you'll see here that I have this number at the bottom. If I click on this, this gives me a quick way to edit this mate. So I actually want to be minus 0.0625. And that updated itself nicely, and we're ready to roll here. I'm going to turn shaded with wireframe edges back on. Now we're ready for our next mate. Now what happened is I have locked that mate into place, but I do not have a rotational mate in place. Now this is where Inventor can be a little confusing, because you may want to try and parallel mate these two surfaces together, especially if you were a SolidWorks user in the past. Inventor actually uses the origin components, which are the planes and the axis alignments, or center points within each part to help mate things together in a mid-mate fashion. So when we first originally started our second module and I had you create something from the center point out, or from the center plane out, this is where that becomes more important, because now what we need to do is we need to actually take and mate the two planes together. Now we can either use the origin of the assembly, or we can use the origins of the parts themselves. So what we want to do is find that center mate, which is on the XZ plane for each part, click on it, right click into our space and hit Constrain. You can also hit Constrain up here in the ribbon bar. Now with that ready, it's already got the selection for the first mate. We only need the selection for the second mate. So I can come over to my tree, find the XZ plane component, and you can see in the graphics window that visual representation, and mate those two together. Now you'll see that they're backwards, no big deal. We'll mate flush that, and that flips the alignment into position. You'll see here that I'm actually below my surface. Now that's just because that 62 thousandths wasn't quite correct. The casting is a little bit bigger. So what I actually want to do is change the mate of that face. So I'm going to go ahead and hit apply. Now that I realize that I need to have this surface flush, that this is a finished cast surface, as well as down here where the casting is itself, I want to go ahead and mate those two together. Well, what's going to happen is it's not going to allow me to do that. Now there are a few things you can go through, and you can go through and diagnose the relationships with this, but because I know that I created that mate before, I know that I actually want to go through, cancel that out, and I want to take this 63 mate, and I either want to delete it or I want to suppress it. Now if I suppress it, that mate will still be there, but it will turn itself off, so that if I did want to use it in the future, I could turn it back on, and I'm going to get another alarm, and I'm going to have to go through and change my mates around. What I'm actually going to do, I'll go ahead and delete it since I'm not going to need that. I'm going to hit Constrain again. I'm going to hit that front top surface that's actually a finished surface on both components with a flush, apply it, cancel, and I'm done. So that pretty much fixed that part. So now that I have my part in my assembly, my stock in my assembly, I actually want to place these two components within their folders. Now the reason why I like to do this is if you are going to do a very large assembly with multiple parts being machined at one time, this helps keep us kind of organized a little bit in what we're wanting to do. So within this, I'm going to take this front pump cover to customer parts. I'm going to drag and drop it in. I'm going to take my stock and do the same thing. Now if I had multiple stocks and multiple parts, it makes it easy for me to come in, right click on that folder, and turn on and off the visibility of each one. That way, whenever I'm in HSM and I have multiple components and multiple structures designed for a setup, I can quickly come in and turn them on or off. Now, I have seen other customers and other people use operation folders. They will organize everything within op1, op2, op3, op4, and so on. That is also a good idea. However, I think that you can actually create and add new folders internally inside each one. Whoops, I nested it incorrectly. So let's go ahead and drop that out like that and nest that folder in here. So now you can actually have an op1 folder within each component. That way you have a kind of a more fastidious organization. You can actually come into your customer parts op1, op2, op3, op4, and so forth. So a little pro tip there, just being a little more organized and quickly being able to select things from your menu. So now with that selected and ready, I'm pretty much ready to program op1 on this part. Now I'm ready to insert and place the proper fixture components. Now with this part, and for sake of time, we're just going to do this in a simple op1, op2 fashion with maintaining the assembly. And what I'm going to do is we're going to program our op1 side. which is going to be the majority of our programming here. That's going to be our boss feature, as well as our radiuses and things like that, similar to how we programmed this part the first time. And in fact, what we're going to do is we're going to cut, copy, and paste all of those features from our front pump cover part cam into this new assembly component. So what I'm going to do before I do that is, for this operation, this is going to be on the production floor. So our production setup guys are going to need a little more information. We're going to go ahead and create jaws, especially since now we can't just go and hold this part with parallels and things like that. We're going to actually want to make some nested jaws for these. So I've already downloaded a vise assembly to place into this file to use, but there's something that we need to do before that. So let's go ahead and go into our Home tab. I just like doing that to get to the open screen. We're going to go ahead and go into the correct folder that the vise is in. We're going to go into the tooling folder. We're going to open this CURT IAM. Within this assembly, this is just a recognition of what is inside of the assembly. There's some things that we need to do to get this to work properly and function within an assembly for us, for what we want to do. Now you'll notice that each one of these components is pinned. That means that they are a grounded component. So when we imported this assembly, it automatically grounded every component. Well, I only need the one component grounded, which is the base. So I'm going to hold down Control, left click each one of the components I want to move, right click on them, and turn off grounded. Now with those two components not grounded, they'll move in space, and they can pretty much do anything. So now that they are not grounded, I want to actually constrain them. Now, the reason for this is I want to be able to use this in the cam assembly to be able to position the vise in the correct place and to create our jaw components. So let's go ahead and go to the Constraint tab. We're going to mate this to the vise carriage assembly. Same with the movable. You'll notice the wonderful wooden peg sound that Autodesk has given its assemblies. Some people love it, some people hate it. It grew on me. And now that we have our fixed jaw and our movable jaw mated down to the actual way surface itself, we're actually going to mate this flush here. And for our final mate, because now we have everything where we want it to move, we're going to give this a mate to this face with the amount of stroke our jaws open. Now, that pushed it 8 inches away. Now what I want to show you is that with that mate here, if I right click on the mate itself, I can go into the edit mode of the mate. It's going to pull the dialog box back up. Now, the dialog box may not be opened up all the way. I had it opened up all the way from using it previously, but it should look like this, and if you hit these chevrons on the side, that's going to open up the rest of the menu. Now what this does is give you the ability to do a minimum maximum mate. We could go 12-inch stroke on that, and we can give this a maximum movement and a minimum movement. So what I'm going to do is give this a maximum of 12 inches to move and a minimum of 0. What that's going to do is allow it to stop at the back and stop at its full capability. Now, realistically, we know that we can't travel more than 10 inches with the jaws in. So I'm going to go back in, and you'll see that this has this mate 3 plus or minus on it. Now that indicates that it's no longer an editable number direct mate. It has a variable. So you actually have to come in, right click, edit that, and we have to change this maximum number. There we go. Now we have a more realistic opening and closing of how our JAWS function out at the machine. With that, I'm going to go ahead and hit save, and that's going to save our master copy. Now I say master copy because it's best practice to actually have a copy of the fixturing and tooling that you're going to use in each folder. Now the reason for that is because this position is going to change with each project. Now there are a few more advanced tricks that we can do, but for sake of time and for the easiest and simplest way, I'm going to show you how to do a pack and go. And what pack and go does, it's under save as pack and go, is this function actually allows you to take all of these components and make a direct copy of them and save them somewhere else. And that's what we're going to do. We're going to go ahead and pack and go this assembly. And this is the pack and go dialog box. Now you'll see the source file. That's the location of the file itself. The destination folder, we're going to change this to our project folder. What this is going to do now is it's going to search out all of the component files. So I actually want to copy everything to a single path. That's going to take all of these components and copy them all into one area. I'm going to actually do model files only, as I only want the solids to come in. We're going to search this. And what that's going to do is that's going to parse the file, find all the components, and because there are only 3 components, it was very fast. If this was a larger file, you'd see green running across here as it tries to collect all of the components. Now that it's got all the files into one location inside of the memory, we're going to go ahead and hit start, and that's going to process those files. We're going to hit done. Now I'm going to open up Windows Explorer just to show you that put that in the right location. I'm going to come down here, Pluralsight course. Now, our original IAM file, and this is just the assembly, was in here in Pluralsight tooling. If I come up to my customer folder, what you'll see now is you'll see I have that Kurt Weiss, and every component and piece to it has come in with it. So now this is one piece that's going to be opened within our part folder and used from here. So the significance of this is that this will now be permanent within this assembly once we put it in there. I'm going to close this file out, go back to our front pump cover, and I'm going to insert and place that assembly. This is what's called a sub-assembly, as it itself is an assembly within an assembly. So this is our fixture and tooling sub-assembly. I'm going to place it out here in space. I'm going to right-click OK. Now you saw that I could click multiple of them. I recommend that you save multiple copies and rename each copy if you're going to have multiple vices in there. Otherwise, what happens is when you go to move this, and we'll show that in just a few seconds here, it's going to change each time. Now, I'm not ready to use this vise just yet, so I'm going to go ahead and move the vise into my fixture components. Drop that in there. Right-click on the folder and turn the visibility off. Yes, that's fine. We're not ready to use it yet, so I don't need to worry about it.